Good morning. My name is Sylwester. I work at Plix. I'm a CEO. Let me start my preso in a minute. Something with colors. Okay. Yeah, wires. Okay, you have to stay here. All right, thank you. Do you know what the Internet Exchange Point is? Here in Budapest, you also have such thing which calls BIX, Budapest Internet Exchange. It's owned by, managed by Kalmar Zoltan. Probably part of you know him. Internet Exchange Point is a place where, which works like PABX. Plenty of big switches connected to themselves in one big single layer 2 area where ISPs and telco operators comes with their networks connected with 1 gig, 10 gig, several 10 gigs, and they are exchanging traffic through this equipment. This is definition of IXP from Wikipedia. It's physical infrastructure through which internet service providers exchange internet traffic between their networks. In most of IXPs, that traffic goes through BGP protocols, so all networks know each other. It works because it's pretty fast, a lot of networks in single place, and it's cost efficient. Plix has started an internet exchange in 2006. Actually, at the end of this month, we will have 7 years of working as an internet exchange point. In the meantime, most of our customers ask us for build a place where they can install their equipment, their networking equipment. So we have developed a data center which was small at the beginning for 150 square meters. Now we have more than 600 square meters and more than 100 racks already sold. We also have a lot of additional services for these providers. So we mostly work with ISPs, telcos, and not with direct customers, home customers, and business. We are located in the strict city center of Warsaw, a building which was one of the first skyscrapers in Warsaw. It's Lim building. Half of this building is a Marriott hotel, the other half is office space. So why we have chosen that location? Because it was the first big, tall building in Warsaw. And when we were starting this business, a lot of radio links were installed in the city. And because that building was really high, 140 meters at the time, a lot of radio links were going through this, the mast on the top of the roof. As I told you, we have built a data center. At the beginning, it was a small data center called Plix DC1 for 150 square meters, then another 100 meters for Plix DC2, and then last year we have built another 300 square meters. In this building, you've seen on the previous slide, we have plenty of cables, and we have fibers everywhere. What is more, this building is heart of Polish interconnect, heart of Polish network providers, because every link coming to Poland goes through this building. That's why such point as Internet Exchange Point is located here. We have equipment on -1, -2, +1, +3, +13, +42. These floors are all taken by some ISPs for connectivity. As I told you, all ISPs, all telcos in Poland are here. That's why we've built Internet Exchange Point here. We have more than 150 fiber cables coming to this building. So it's like in US, there are some hotels which has been migrated into big connectivity hubs. So we also have hotel, what it calls Marriott, but it's not connectivity hub, but the building is. How it looks. In most cases, the customers comes with their equipment, install some switch, then connect to everything what's possible. And what's possible? Big tier ones, all of them for IP transit, IPTV, VoIP exchange, cross connects between networks, and of course, exchange of IP traffic inside PLIX infrastructure. This is how it looks. These are shared racks for switches. You see a lot of cables. These cables are direct connections between switches, between customers and our equipment. In terms of traffic, we are hitting 300 gigs. We have now more than 220 members, and around 40% of whole Polish traffic goes through our switching fabric. In terms of figures, PLIX is the biggest IXP in Poland, 9th in the world, in terms of members and traffic flowing in. You can see this is a 24-hour diagram of our traffic, how it goes through all these years. In September 2009, we had around 70 gigs, and each half a year we have more and more. As you see, March 2010, 82 gigs, September 2010, 100 gigs, then 120, 150, 200 gigs, 260, now we are hitting 300. What it means? It means that we have to think more about changing equipment, about having enough capacity to flow this data. 300 gigs in one single area, broadcast area is quite a huge problem. As you see, number of ports. I have data for 2009, 2010, and 2011. How many switches we had developed through this time? What was the growth in traffic in terms of ports and other stuff? So you can see that year to year, it's more than 100% of growth. It's not easy to maintain such big infrastructure, so we have a lot of people. I will tell you about all this thing in a moment. Now we have more than 220 customers, so if you come to Poland and try to make any business which is telco related, you have to be here. I've told you about that data center which we started in 2009. It looks like this. It's located on the first floor of Slim building. We have full cabinets and shared cabinets you've already seen with the switches and a lot of cables. Some technical data, that 3 kVA per rack, and of course DC power, which is very often used in telco companies. When we have sold all space, which was 6 months after opening the data center, we had to find some another solution, another space, and build it out. So we've got another 100 meters on third floor, and we've installed also the same. What is also very funny, we've got space where previously one of the banks was installed. So when the bank was moving out, they have left the big bank safes, vaults. When I saw it, yeah, This is the place where we should place some servers. There will be secured and so on. So we've made it. As you see at the right bottom slide, these are doors to that safe. The doors weighs 1,500 kilos, so 1.5 tons. Of course, the space, the needs of our members are growing all the time. That's why they've asked us for more space. And last year, in February, we've started to build the third data center. This is a diagram for racks in the data space. In the middle, there is already a cage of one customer from the United States. And you see there are rows for racks, for equipment, for networking equipment. This building, which has been built 22 years ago, had enough power capacity, which is the most important in IT. Yeah? Electronic devices works better if they have power. That's why we have 12 megawatts of power in this building, 2 power feeds, and a lot of UPSs, 3 diesel gensets, and of course FM200 plus Vesda for gas fire suppression. So it's completely tire-free plus data center. It looks like this. We have more capacity, more power, more cooling per rack than it was before. We have also a raised floor, which was not possible in the previous locations, and we are still filling this space with the racks. These are trafo stations. In this building, I've told you 12 megawatts, 16 trafos, 2 15 kV lines coming into the building from 2 different substations, from 2 separate power districts. And we are using in total 5 megawatts of power in the whole building. What is good? If you buy 5 megawatts, you have cheap energy. This is also very important if you have a lot of customers with a lot of equipment, which takes a lot of power. This is how it looked before. I had the whole presentation, but I don't have so much time to show you how we've built it. But the story is that we had around 2 weeks to build it out. 300 square meters to give that customer I've told you in the middle of the data center. The problem was that, you see, there are some pipes just on the top. They had to be removed. Unfortunately, that were the pipes for rainwater for whole building. If you see 140 meters, a hotel and so on, this building works 24/7. So removing it means you have to do it during a night, and you have to switch off water. You can't do it in the rain and so on. So it was not easy. That's why we've got 2 weeks for building that site, and finally we've made it. But there was more than 100 people working 24/7 for a week. There was a lot of equipment which needs to be installed, and it was quite an advantage. Now it looks like this. So previously, now. This is the cage of this customer. So this photo has been made when this customers moved in. Of course, gas fire suppression. So these are bottles for FM200. UPSs. We are using APC UPSs with 160 kVA each, and we have multiple UPSs for this scenario. We also have 2 additional power gensets. In total on UPSs, we have 1.3 megawatt of power in this area, which is quite enough because we've counted that 600 kilowatts should be enough. So we have more than twice more. But I was about to talk about challenges of going from 0 to 300 gigs of traffic, so let's do it. This is our rally car, Plex rally car. It has 500 horsepower. It's Mitsubishi Evo 9, if you know what does it mean. This car makes 300 kilometers in less than 30 seconds. We've made it in 7 years, which is also quite a big idea. some history facts on this process. First of all, we started on 1st of March 2006 with 2 switches. One was Cisco 2970, and the second was Cisco 3750. So, few members, 6 gigs of traffic, and more going. It was a star topology, so everyone was connected in a single switches, but it was not enough. In 2 months, we've got lack of ports in the switches, so we had to find another solution, which was not easy at that time. So we've invested into Taiwan switches, which called EdgeCore. We've connected it together with Cisco's, and we've seen the first outage in our network because EdgeCore was restarting all the time after connecting to this one big broadcast area. But we were using it for some time. We've changed the software. It looked like this one. This is a real photo from 2007. The problems. We had unstable OS, so the switch was rebooting from time to time, once a month or something like this. We never know if it works or it's going to be rebooted in a few minutes. He had no Mac learning, which is, if you have a lot of Macs in a single area, it's not easy to do it. No loop protection, so everyone could hurt our infrastructure. So we decided to change a vendor. At that time, there was a company called Forsten. Now it's Dell Forsten. We've got small pizza boxes, S25Ps and S50Ns. We've connected them in a stack. It worked. We've ordered some of them, as you see. That was also a star topology, so we've connected stack of all these switches and connect all customers into one big area. But we've also got into the same problems. No Mac learning, only static Mac addresses per port, no BPDU filtering, CDP and other stuff. So we've got the same, but the equipment was a little bit more stable. So we've got a solution from Forsten. We need to upgrade from one operating system to another, which was newer. We've made it and nothing has changed. Yeah, but what is more, we've got more problems with the stack. So we've decided to move to one big box with all features inside, with high capacity, with no stacks, with high capacity backplane to support this traffic. At that time, it was more than 100 gigs, so it was a reason to do it. So we've got a big box from EdgeCore. It doesn't work anymore. We've got some MPLS switches because we've decided it can be MPLS. It was Corrigent Networks, but it was not a solution for us. We've looked into Cisco, but it was also not a good solution for us because Cisco was not able to get high density of 10 gig cards in such small box. And after all, we've decided to buy Forsten C300, a big box with a lot of ports. It's a data center switch, so it should support a lot of port, lot of traffic, and so on. We thought so. This was our topology at that time. So we've placed Forsten C300 inside, connect all other Forsten as access switches. I know. It looked nice. We were ready to migrate, but it was not easy. This is real photo. This is also real photo. But finally, we've got a very good idea. It worked. It was clean after that. It was about to be our solution. But then we wanted to switch all functionalities in this equipment. And we had a lot of problems. The same problems as we had in previous. So after several outages, line card rebooting, memory leaks, and other stuff, we've decided to find another solution, and we went velvet. We've started to buy extreme switches. First of all, small switches, We've made some tests and it became all features are working and equipment is not rebooting, so yeah, let's do it. And since that time, these switches are the most stable ones in our scenario for all these 7 years now. Then we had more traffic than 100 gigs, so we had to put something in a core, and we've installed also extreme switches. We know that it works. With a lot of 10 gig ports. It looked like this. So stack of 2 big 10 gig switches and everything connected with LACP, with LACs into it. This is a weather map from that time when we were hitting almost 200 gigs. Unfortunately, that stack was rebooting from time to time. When we started to switch some functionality like S-Flow to see what traffic goes from which member to which one, it was rebooting. In the meantime, Extreme has found and developed a new X670 with twice more 10 gig ports in one single switch. So we've decided to do it. We've bought it, and we have removed stack and installed MLAC. Multi-chassis LAC. This is our map for that time. But when one of the uplinks flaps, switch starts to lose or switch to null broadcast packets. So another problem. Already it's already fixed in software, but at that time it was quite hurty to us. So we've decided to move from one solution, multi-chassis LAC, to IPS, and we are still using it. This is our map of our switches and connections for now. This is how it's done at that time. So we have a lot of fiber cables. It's directly Plex infrastructure. This is copper for Plex switches. These are these extreme switches with a lot of cables in and customers working. This is the same but fiber switches. And now we are hitting 300 gigs and have more than 150 10 gig ports. We have a lot of customers. Some of them are asking for 100 gig, and there is no solution for that. So, not working solution. Everyone tells about 100 gigs, and there is no equipment you can use. So we are waiting for Extreme X Black Diamond X8. 400 gigs, and we want to do something like this. So Black Diamond in the core of our current infrastructure. Our strategy, yeah, IXP makes money on ports, data centers makes money on racks and cabinets, and we are making money on customers, of course. So we have 24/7 service. This is photo of our NOC. We have very active monitoring. It has a lot of resources, but we've decided to cover this cost. This is one of our monitoring system, which gives us most of information what happens in our network. These are graphs from RRD tool for traffic from the last night, and of course engineers. They are working 24/7 on site, speaking English. Sorry, they don't speak Hungarian yet. Maybe it will change. And these are engineers, so you can call them, ask them for anything you want, and they will speak to you as an engineer, not lady giving you a ticket number and somebody will contact you within 24 hours. We have quite good support from vendors. As you see, that black cabinets in data center were cabinets from APC. We use switches from Extreme, and we have very good support from their side. We also have a lot of TV broadcasters in data centers and a lot of content delivery networks like Google, Akamai, CD networks. For example, yesterday we've got a new rack of Google switches, as you can see, 18 servers with more than half petabyte of disks inside. It weighs 700 kilos, and probably it will give us another 50, 60 gigs of traffic. We are also part of community of PLNOC. This is the biggest Polish networking event. It comes next week in Warsaw if you wish to come. It has more than 650 attendees, so it's quite a big event. There is also an association of Polish ISPs called HINET, and we are also part of it, and association of EuroIX, European Internet Exchange Association. PIX is also inside, that's why I know Kalmar from. Okay, if you're interested in joining or more information how we've made it, you can catch me here or send an email. Thank you. If you have any questions, I will be here.